So I had one of the viewers contact me about a AC issue they're having, but I at least want to do something like this to give some sort of idea, and this is going to be kind of a quick and dirty explanation of it, but this hopefully will help some folks if they're not familiar with AC and how it traditionally works in most cars. If you get into the older cars, you're probably going to have a little less electronics and that kind of stuff involved. But overall, it's going to be the same basic idea of just pretty much a fluid that goes from liquid to gas back to liquid and on and on and on through the cycle. So in essence, what you've got is the main components is the compressor and your condenser. You have a dryer, an expansion valve, the evaporator, the blower motor regulator slash resistor, the recirculation control box, air box, a lot of times it's referred to as. You also have your pressure switch as well as your fans, and those are under the hood. So pretty much everything in this area here, including the ECM and relays, are likely going to be under the hood of your car. They could be in other locations. Now you also have the AC controller, which is also a lot of times the module that you actually move the dials or knobs or buttons to choose your temperature and or mixing of the air. Of course, when you choose your selections, it's going to control the doors on the air box. That's usually over on the passenger side under the dash or in the center of the dash. You will not see this without having to get up underneath the dash for the most part on most cars. But you'll also have a flap that allows fresh air in from around the windshield. The fresh air grills will dump into a door that allows that to come in. Or of course that door will close if you put it on recirculation, and the recirculation door will open and allow the air to come in from the cabin and get recirculated within the cabin itself, thusly taking cooler air and making it even colder, whereas you're taking warmer air from outside and making it colder. So I guess first and foremost, the person that contacted me was having no air conditioning at all. And of course this can be due to either or both electrical or some sort of mechanical issue with the flow of the refrigerant. So the whole idea is that you're going to take the compressor to move this liquid or gas form of refrigerant depending on which side of the system it's on. So you have, as I've marked here, high pressure liquid, then you got low pressure liquid once it goes through the expansion valve into the evaporator. Once it hits the evaporator, that liquid is what cools the air inside that evaporator, and as it does that, it of course condensates, and that's why you get the water underneath your car that drips off inside this box, and this box has a hose that goes outside your car. Now once it cools the air, that heats up the liquid refrigerant and turns it back into a gas. So it comes back out through your expansion valve, heading back to the compressor under a low gas. So you got low pressure gas heading into your compressor. So your compressor then takes the gas, passes it back around, and creates a high pressure gas through your pipes, back through your pressure switch, and then into your condenser. Once again, you're into a grid that is cooling the fluid, and as it cools that, it becomes a fluid again. So once it becomes a fluid, then it passes through the dryer here, and it becomes a high liquid, so a high pressured liquid, and then back on through the circulation again, in through the expansion valve under a low liquid, because the expansion valve is going to lower the pressure so it doesn't blow the box apart here, and then keep it flowing. So that's your circulation of how the refrigerant goes through. Now, such as most people run across, it's not normally a mechanical failure unless the compressor itself is locked up or you got something clogging up the system. Most of the time what people run across is electrical issues with AC when it doesn't work at all. If you've got some sort of leak and you don't have any pressure, of course, then yeah, you're not going to have any system because you don't have any fluid in there. And if this pressure switch doesn't see what it expects to see, it will not send a signal that it's okay to go ahead and run the system. So if your pressure's too low or too high, that switch will let the system know that, hey, we don't need to kick this on, because if we kick this on, we start going through and we create more pressure, we can start blowing stuff apart. Or if it's too low, it's just not going to do any good. On top of, you may not have enough refrigerant in the oils within that system to keep the system from getting worn out and destroy the compressor and whatnot. So the clutch gets a signal. Typically, on most cars I worked on, it comes from the ECM. So your ECM is going to take that information coming from this pressure switch, as well as many other things, engine idle speed, or running speed, all sorts of stuff that comes into your ECM, and that's your engine control module. So it's going to take all that information and look at it, and then it's going to send a signal back through, most likely over a relay, and it's going to activate that relay. Then that relay is going to actually allow the voltage to close the circuit and activate your clutch. And once that clutch is activated, that creates, just like in your engine to your transmission clutch, if you got a manual, it creates a friction plate against the pulley. So that pulley is flowing freely until that clutch activates. And when it activates, it engages the shaft in the compressor to rotate your compressor pistons or valves, depending on the type of compressor you have. So once it activates that, of course, now your belt is not just flowing freely over this pulley and idle. It's actually engaging and putting resistance on the engine to maintain its idle or speed. So that's where you'll notice when your car is setting and just idling and the AC's on, you'll hear typically like a light click. Just depends the car. Some of them are loud. But you'll hear that, and what you're hearing is that clutch engage. And when it does, you'll notice that the RPMs of the engine will typically dip down just a little bit. And when they do that, that shows you that the engine is under load and that it's having to work to turn this compressor. Of course, if the compressor is getting worn out and it's getting a lot of friction, the harder engine's going to have to work. And then I've even seen to where compressors lock up, and next thing you know, you're slinging belts because you're just ripping that belt to pieces because this pulley just won't run. I've seen clutches seize so that the clutch is constantly engaged, so the compressor is running all the time, even when the system's not on. So you can run into all sorts of oddities there. That's kind of what you're looking for. If you've got a system that's not working, it looks like everything mechanical's there, you're holding your Freon, you're not seeing any leakage, it's very possible something with electronics. So there's several different ways to hunt this down. You should be able to find information on this pressure switch to see what exactly it is sending, so that you know what kind of range, and most of the time that's in a resistance or an ohms reading. And you're going to measure that and see what it's putting out when the car is not running and then when it is running. Now, if it shows an oddity when it's running, and it shows that it's really high or it's really low, then of course there should probably be no actuation to the clutch. So you're of course not going to have any air conditioning. But some things I've seen in the past is an easy way to test if it's that pressure switch is find your relays, and you can jumper the circuit and force the compressor to engage, or the clutch to engage, so that your compressor can commence to pumping. You want to be very careful doing this, making sure that you're not going to blow your compressor apart or tear up other components, because if your compressor is seized, you can run into issues there. And you can check the compressor before you ever do anything. Of course, with the engine off, you reach up here and grab this clutch plate. It's probably easiest from underneath on the XK8. Some cars it's pretty easy to get from the top, but if you can get to it from the top, great. And just grab the actual clutch part. See if you can move it freely or not. If it moves freely by hand, then you're most likely not seized up at that point. So it is a good time that you can actually try to force the engagement of the clutch and see if the system will start cooling. If it does, most likely you've probably got a bad pressure switch or some sort of loss of communication between the pressure switch and the system, the ECM. So that's kind of an easy way to find out things like that. You also have other things such as, okay, the compressor is running, but I'm not getting any cool air coming out. Well, then that's going to lead back to your blower motor, or possibly even your blower motor regulator / resistor. Most cars have that nowadays. Some of the older cars didn't even have that. They just hooked it on the blower motor, and there you go. It just ran. But we're talking about really old cars at that time. Most of your modern cars, even as far back as the 60s and 70s, should most likely have some sort of regulator or resistor with the blower motor. So either one of these components could be bad. The easiest way to check it, I've always found, is if you can, get you some sort of 12-volt power supply and just hook it straight to the blower motor's leads. Find your leads. You should have typically a power and a ground lead for that blower motor. Hook up your power and ground to it and just let it run for just a couple seconds and then disengage it, because you don't want to burn it up or anything. But if you can hook it up to some power and ground and your blower turns, okay, your blower seems to be fine. You probably got something going on with your regulator. Once again, your regulator is going to be much like your switch. It's likely going to have some sort of resistance range that you're looking for, because this is the module that's used to control how fast your blower spins. So if you only want a low fan speed, then that regulator is going to control the voltage going to your fan, or the current going to your fan, so that your fan spins at a much lower speed. And of course, at a higher rating of fan level that you select, the faster that fan's going to blow. So the higher the current it's going to let come through. So that's kind of what you can run into there. And then when it gets into your doors, when you're selecting if you want it to come down at your feet for a low, or toward your chest as the mid, or the high hitting the windshield or your face, those are all going to be typically, on most modern cars, they're going to be controlled by a little micro motor. And a lot of times they'll have little switches inside there that when the door is opened or closed, there'll be a switch that gets pressed to let the control module know what position these doors are actually in, especially on cars that are going to use some sort of auto AC, or the ability to allow a temperature choice, and it maintains that temperature choice. Those kind of things are definitely going to have those little switches, because they're going to be monitoring, okay, what is the temperature in the car, what is my chosen temperature I'm trying to achieve, and they'll control all these things automatically to try to give the user temperature and comfort level that they requested from the device. So your fresh air, of course, same thing with your recirculation. Those are going to be micro switched, and so the AC will know what's going on, especially when you're trying to defrost a windshield or something like that. So keep that in mind. Even though in the winter you are trying to defrost the windshield and you're also trying to warm the car up, it's still using your air conditioner to do that, because your evaporator will help pull the moisture out of the air so that you don't have that moisture barrier up on your windshield. So that's why the old cars that didn't have air conditioning in them, they wouldn't do real great jobs of defrosting the windshield at first, because they didn't have anything to pull the evaporation away. So the condensation would build up on the actual windshield. So hopefully that gives you all a good indication of where to go, and maybe hopefully explain some of that y'all may or may not have understood. So once again, be safe when you're working on this kind of stuff. Just like always, try to get your manuals, try to get some sort of information officially from the manufacturer if possible, to help understand exactly what does what, because you're definitely going to have all sorts of relay or relays. There could be 2, 3, 4, 5 different relays that control different things within your AC. So be sure and do your homework before you mess with this stuff. Definitely suggest you read up a little bit on how to handle refrigerant. Preferably take it to a professional that can recover it properly if you don't have those tools. And just be safe with this kind of stuff. This is the kind of stuff that you can get hurt real quick, because that Freon is extremely cold and it can create a frostbite situation very quickly. So be careful opening any kind of these connections on the hoses or valves under any kind of pressure. It's always best to work on that side of the system with it recovered from the system, so that you're not taking a chance of having that happen. And always make sure that your system stays sealed. Don't start working on it, leave it open, and then leave it for a couple of weeks and come back to it when you got time. You do that kind of thing, you wind up getting dust and debris into the system, and you wind up taking components out real fast. So if you're going to work on it and have to come back to it later, it's best to go ahead and reseal it back up as quickly as possible, and try to keep plugs and things. If you have plastic or rubber plug covers that you can put over openings, definitely do that to keep things from falling into the system and causing further issues later on down the line. Another quick thing I didn't go over was your two fans up here. So you have a radiator fan and you have a condenser fan, and it's going to engage one fan all the time. The other fan will kick on whenever it sees that it either needs to cool the radiator more, or typically it'll kick on with the compressor when you start flowing the Freon, because it's going to need extra volume to help cool that condenser down and bring that fluid down to the proper temperature so that it can work properly. So hopefully this helps. This may create even more questions, but we'll go with it from there, and hopefully this will make it to where it's easier for you to work on your own vehicles and be able to knock out some of this work without having to pay so much out of pocket. So once again, thank you all for watching.